Hello students, welcome to RLD Academy. In this video, we are going to discuss about the domain of the function. In particular, we will be discussing two problems, especially for IIT JEE main exam. This is the first problem. You can see here one function is given, this one. So this is the function f of x equal to 1 upon 4 minus x square plus log base 10 x cube minus x. There are 4 options for this problem. We need to choose one option. Now before discussing this particular problem, we need to understand what is the meaning of the domain of the function. That I will discuss first. So what is the domain of function? Now, if one function is defined for real to real, means it can accept some real numbers and it can produce one corresponding real number. Now, set of real numbers for which the function is defined properly, that set is called the domain of the function. It implies that all the real numbers we cannot apply to the function, cannot be the input of the function. So that we need to be careful that which real number we cannot apply to the function. Now we need to consider these following terms or functions. There we can discuss that which input or which real numbers we cannot apply. Like this one, first one, square root of certain function is there, right? There you can understand that for this thing, the square root of any positive number that we can compute. So square root of 25 is 5. Square root of 4 is 2. Even square root of 2 is 1.414, like that. Okay. So but this square root could be one rational number or irrational number. But anyway, any positive value, if g of x is positive or 0, it could be also 0, then we can compute its square root. It will give you another real number. So the here condition is that g of x should be positive. But if g of x is negative for certain value of x, that times the square root of that negative will give you some imaginary number. So here that function is not defined because function is for real to real. Thus we have to exclude that case, that when g of x will become negative. Okay, so we have to choose only those range or those set for which g of x will be positive or equal to 0. Thus we need to consider g of x more than equal to 0. Now similarly for this one polynomial is given in this form, one numerator and one denominator, p of x upon q of x. In that case, this one, if anything is divided by 0, that is not allowed. No? So if anything is divided by 0, that outcome could be infinite. So that will restrict. We should eliminate that choice. So q of x could not be 0. So here we will consider, we will exclude this inputs x, such that q of x will be 0. Okay, so we will solve q of x equal to 0, and that solution should be excluded from the real set. It should not be within the domain of the function. Next one is this log function. Any log function, log of h of x, the base could be 10, could be 2, could be other things, whatever it is, but h of x, it can take only the positive numbers. Okay, positive real numbers. Thus h of s should be positive more than equal to 0. Even 0 is not included. Log of 0 is not defined. So be careful here. Log of some h of x, their h of x strictly it should be positive. But you see in square root of x, for square root of g of x, there it could be 0 as well. So g of x would be more than equal to 0. So equal sign is there. Okay, but remember here there is no equal sign. you should remove the equal sign. All it is strictly positive. And for this kind of denominator cannot be 0. So these three things we will check, then only we can solve the problem. It's not very difficult. So now we are going to solve this problem. F of x equals to 1 upon 4 minus x squared plus log 10 of this x cube minus x. So this is the function given. Now you see this function is having two terms. One term is 1 upon 4 minus x squared. Other term is log function, log of x cube minus x. So first term, when it is defined, so you see it is of this form, numerator and denominator. Okay, the denominator we should find these solutions, 4 minus x squared. So now we'll consider this part, 4 minus x squared, it should be not equal to 0, right? Thus, so this a square minus b square form, so I can 2 square minus x square, so a plus b, a minus b I can consider. So it is 2 minus x times 2 plus x. So these are the two product, and that should be not equal to 0. Thus this should not be 0 as well as this should not be 0. Okay. Thus x cannot be 2 from here, x cannot be 2, and from this one x cannot be minus 2. So these 2 points, x equal to 2 and x equal to minus 2, these 2 points could not be in the domain of the function, because that time 1 upon 0 will come and that will become infinite, right? Now second term, this log function we need to consider. So for that I have said that log of something, this h of x, here in this case x cube minus x, it should be positive, strictly. Don't put equal sign here, okay? It is more than 0 only. Okay, now we need to understand for which value of x or which range of x this will remain positive. That is now question. Now for this, now here I can take x common, then it will become x squared minus 1, and then again this 1 I can write 1 squared, so a squared minus b square form. Again I can have two factors here. Thus we'll have x times, and from this one we'll get x plus 1, it is x minus 1. So there are three terms, the product terms. One is x plus 1, x minus 1, and this product should be more than equal to 0. Now here is the tricks, how to find the range for this kind of equation. Okay, so it should be equal to 0. That I'll show you. So what I'll do, first I'll locate the points when this function will become 0. So if it is 0, that means x could be 0. So that is one point here. The next one is x plus 1 equal to 0. That means x equal to minus 1 here. Next one is x minus 1 equals to 0. That means x equal to 1. This is the point. So I have 3 points for these 3 solutions. Okay. Now I need to find the range, because the x can take any value, minus infinity to plus infinity. Now for which range, which set of real numbers, this product will be positive, that we need to understand. Now if you consider one point here, suppose this point is 2. Okay, so if 2 is there, so if I can put x equal to 2, it is positive. 2 plus 1, obviously it is positive. Why? Because this 2 point is with respect to this minus 1, it's on right hand side. So this is positive. And this one, x minus 1, it is again positive, because 2 minus 1 is positive, because this point is right side to this one point. So if I consider one point here in this range, 1 to infinity, anywhere more than 1 and up to infinity, all the points will be on the right side of these 3 dots. That means all the points, this one, so every term will give you positive value. Thus total product will become positive. Thus this range is positive. Remember, the first range, this range is always positive, right? So what I'll do, I'll put it's positive to indicate that this region is positive, right? Now this is another region from 0 to 1. Now if I choose any one point here, suppose it is 0.5, for this point will be on the right side of this one and right side of this one. So for this and this, these two functions, this one and this one, it is positive, because if I put 0.5, so 0.5 this is positive, 0.5 plus 1 is 1.5, it's also positive. However, this 0.5 for this term, this 0.5 minus 1, this will become negative. As 1 is become negative, total will become negative. Others two are positive, this is negative, thus total product will become negative. So earlier 1 to infinity, this range was positive, and next range is going to be negative. It's alternate, okay, because only one, this one, for this one it is becoming negative, all others are positive, right? So this is negative. So what you have got the idea? It is the first one, so I will consider these dots, the solution points, and then the right side, rightmost side region, that I will assign as positive. Next one will be negative. Again next one will become alternate, positive, because that time these two will be negative and this will be positive, so total is again positive. So this is positive, these two will become negative, thus negative into negative is positive, okay, so again it will become positive. So it's alternating, positive, negative, and again positive, and again it will be here, it's negative. So if you have more points, just what you will do, you will take some these partitions, rightmost region you will consider positive, next one negative, again next one positive, negative, again positive, negative, in this way. It is very easy, okay. So we can identify the regions where it will be positive. So I need to get the positive regions, okay. So here I will find two regions, this and this. This region is positive as well as this region is also positive. So what are the regions? So this region is -1 to 0, and this one is 1 to infinity. Now remember, it is not equal sign. There is no equal sign. So this term number -1 should not be included, because at x equal to -1, this function value will become 0. Okay. Similarly, 0 is not included. So 0 and -1, it should not be included. But if it is x is more than -1 and if x is less than 0, then in this region the function, this function is becoming positive. Okay. Similarly, if x is more than 1, then also it is positive up to infinity. Thus we will write in this form: x belongs to this -1 to 0, and I will put this first bracket to include that these two terms are excluded, not included. If they are included, then I will put it here third bracket, square bracket. Okay. So there is one difference of square bracket and first bracket, right? And second one, this region is 1 to infinity, and infinity always the first bracket, and here 1 is excluded, that's how it is the first bracket. And these two I need to take union, just two range we want to add, so they are not overlapping at all, just we'll take the union of these two set, right? So this is the case for this log 1. Now we need to combine these two. I have two terms. I have already got x cannot take these two value, 2 and -2, and x can take these values, -1 to 0 and 1 to infinity. Now I need to combine these two, okay, this and this one. So already I have got this region, okay. So this is the positive region, this is the positive region for the log function. Now I need to put this condition, this one, x cannot take 2 and -2, so where is 2 and -2? So these are the 2 points. This is your -2 points here, and this is the +2 points here. Now you can clearly see that this -2 is already in the negative one, so it is not in this range. So it will not have any impact on this case, okay. So we can exclude this thing, already it is already there. Now this point, this x equal to 2, it is within the range 1 to infinity, this range, okay. Now I need to exclude this point x equal to 2. So what I can do, I can consider one range from 1 to 2 and next one 2 to infinity. I can split this total region by two regions. One is from 1 to 2, other will be again 2 to infinity. Where 1 and 2, these two are not included, again this 2 should not be included. So what we can do, we can now define the domain of the function f of x as x is element of belongs to these things -1 to 0, that is fine, there is no problem at all. But here we will modify these things 1 to infinity. I will consider these two separately, 1 to 2 and 2 to infinity, taking one union. So I have these three separate regions. One is -1 to 0, another one is 1 to 2, another one is 2 to infinity, these three, and it will be union of these three. Okay, so this is your domain of the function. Thus these are the choice, 4 choice. Now you can notice that the option C is exactly matching, so C is correct answer. If you enjoy this video till now, can you please press the like button? And if you wish to get this kind of videos, then you can press the subscribe button and bell icon. I will be adding lots of videos in this channel. Now I will consider the second problem. The second problem is this one, f of x equals to square root x squared plus 2x minus 8 upon x minus 3. Okay, so how to handle these things? Now see. So first what we will do, I will consider this numerator part. I will go for these factors. So x squared minus plus 2x minus 8, that I can have two factors, x minus 2 and x plus 4. You can easily see 2 into 4 equals to 8. So minus 2 into 4, this will become minus 8. And here it is 4x, here it is minus 2x, 4x minus 2x will become 2x. Okay, so its factor is x minus 2 times x plus 4 and denominator is x minus 3. Now to get numerator denominator, so square root in one place, what I will do, I will multiply both numerator and denominator by the same factor x minus 3. In that case what we will get? Here we will get x minus 3 whole square, and square root of whole square to become only x minus 3, right? So thus what I will get? I will get square root of x minus 2, x plus 4 and x minus 3, that I have multiplied both numerator and denominator. Okay, so this is the square root in numerator, and denominator is simply now becoming x minus 3. Okay, so I write in this form. Now I need to find out the domain of the function. Okay, so what is the domain of this function? So from here you can notice that this is the denominator, so obviously it cannot be 0. If it cannot be 0, then what is the meaning? X cannot take value 3, so x is not equal to 3. This is one, and from this one it is a square root is there. So square root of gx, and that gx should be positive or equal to 0. Okay, that it can take. So that we need to consider when this product will be positive or 0. So that already I have discussed. Again we will repeat the same concept. You can see. So what I will do, I will make it 0 first. What are the solutions? X equal to 2, x equal to minus 4, x equal to 3. So I will have 3 dots here, x equal to minus 4 here for this one, and x equal to 2 for this one, and x equal to 3 for this one. So 0 is just I have included here, it is not a solution for anything. Okay, so I have got these 4 regions. One is 3 to infinity, another one is 2 to 3, other one is minus 4 to 2, and it is minus infinity to minus 4. Okay, now we need to consider which one is positive, negative, positive. Okay, so already I have said that rightmost area, this region will be positive. Okay, so this is positive. Next one, this one should be negative, right? Next one, it should be positive. Next one, it should be negative, like that. So it's very easy. So what is the range? So positive range is this one, minus 4 to 2. Another positive range is 3 to infinity. Okay, but here one thing, it is square root. So it could be also 0 also. So these points are included. We'll include this one, minus 4 to 2. Okay, again 3 to infinity, infinity, okay, excluded, fine. So what is the x value? So x, the elements of this one, minus 4 to 2, I'll use here third bracket, you can see the square bracket. So to indicate that 4 is included and this 2 is also included, right? Another region is 3 to infinity. So 3 is included, but for infinity we'll put one first bracket always. Okay, this is not a particular number, so we'll consider the first bracket. It's open. So it is closed. Okay, at 3 only. So these two regions, there's some union. One union we'll consider to include these two regions. So this is from numerator, and from denominator x cannot take 3. Okay, so I need to combine these two. So here 3 is included, but it says that 3 cannot be considered. Okay, so I should eliminate the 3. So now the domain of this function should be modified. So this will remain same, there's no issue at all, minus 4 to 2. But here 3 was included earlier from these things, but it says that denominator says that 3 cannot be included. Thus we'll remove this square bracket, we'll put it as first bracket to indicate that 3 is excluded. So this is the domain of the function. Okay. So if you enjoyed this video, please press the like button. If you wish to get this kind of videos in future, please subscribe the button, subscription button, and also bell icon. So thanks for watching.